You know that feeling when you're faced with a problem, maybe something you've learned about before, even solved in the past, but in the moment, the knowledge feels uh, stuck,
Mm.
like it's in your brain somewhere, but the pathway to it is just blocked.
That
Yeah.
frustration,
Right.
right? Not being able to access what you already know when you really need it. That's kind of the puzzle we're tackling today. We're
Well,
diving deep into something called strategic transfer, which is essentially about, well, how we unlock that knowledge on demand.
exactly. And we're drawing on a really fascinating article from 1992 in the Educational Psychology Review. It's called Strategic Transfer, a tool for academic problem solving by Gary D. Fye.
Okay.
And this piece, it really covers a lot of ground. It looks at, what it means to solve academic problems, how our memory plays a role, and even thinks about how we can foster this ability to transfer learning effectively.
And, while the title mentions academic problem solving, the insights here feel much broader than just like the classroom, right?
Oh, so whether you're prepping for a crucial meeting, trying to get your head around a brand new industry, or maybe you're just fascinated by how your own mind works, this deep dive is for you.
Hmm.
Think of it as a way to maybe shortcut your understanding of how we actually use what we've learned to navigate new challenges. We're aiming for those moments where things just click.
Yeah, those aha moments. Like,
Exactly, where you see the connections between learning theories and everyday situations.
mhm.
And we'll try to do it in a way that's engaging without getting too bogged down in overly technical language.
Right. Our goal today is really to understand what strategic transfer is, how our memory and cognitive processes support it, and what the key factors are that either help us use our existing knowledge effectively or kind of get in the way.
Yeah.
We want to explore why sometimes the information we need just pops into our heads at the right moment, and other times it feels completely out of reach.
Okay, so let's get started then. What exactly is strategic transfer as Phi describes it in this article?
So the article gives a very specific definition: the spontaneous access and retrieval, remembering, of previously learned formal procedures for the successful solution of a problem.
Okay, spontaneous access.
Right. The crucial bits there are spontaneous access and previously learned formal procedures. It's not just about being able to recall information if someone prompts you, but about your brain automatically bringing it to the forefront when you encounter a relevant problem.
That spontaneity element really feels key, doesn't it?
It really is.
It's one thing to remember a formula when you're in math class, and you know that's what you should be thinking about.
Uh-huh.
But it's totally different to be faced with some real-world situation and have that formula just pop into your head as
Yeah.
a potential solution without anyone telling you to use it.
Precisely. And to understand how this spontaneous access happens, the article really emphasizes the information processing perspective of learning.
Okay.
This view highlights that the learner is an active participant,
Yeah.
constantly engaging with the information, not just passively soaking it up. And at the heart of this is memory. The article explains that learning involves several stages, and crucially, it's the ongoing interaction between our working memory, that's where we hold and manipulate stuff short term.
Right, the mental scratch pad.
Yeah, exactly.
Yeah.
And our long term memory, where we store knowledge. It's that back and forth that enables us to learn and then apply that knowledge. And that's where transfer comes in.
So it's not just about stuffing facts into long-term memory and like hoping they'll magically reappear when needed.
Not at all.
There's this dynamic process of connecting new information with what we already know and then being able to actively retrieve and use those connections later on.
Exactly. The article also makes a useful distinction between academic problem solving and creative problem solving.
Okay, what's the difference there?
Well, our focus here, based on the article, is on the academic kind. That relies on knowledge and procedures you've been explicitly taught, in a formal setting like school.
Hmm.
Creative problem solving might involve more novel thinking, coming up with solutions that aren't necessarily based on prior formal instruction. They're related, of course, but we're really looking at how we transfer previously taught knowledge strategically.
That makes sense in the context of strategic transfer as a tool. It's about effectively using the tools you've already acquired through learning. Now,
Hmm.
the article also touches on different ways of thinking about transfer itself, like the behavioral view versus the cognitive view.
Yes, it briefly contrasts those two. The behavioral perspective, it largely focuses on how prior learning affects the acquisition of new skills or knowledge.
Okay.
Like, does it make it easier? That's positive transfer harder, negative transfer, or have no impact, zero transfer?
Right.
From this viewpoint, transfer is often seen as resulting from similarities between the original learning situation and the new one, surface level stuff.
Like how learning basic arithmetic helps you learn algebra positive transfer.
Yeah.
But maybe if you're used to writing really informally, switching to formal academic writing could be harder. Initially, that might be negative transfer.
Precisely. Good examples.
Yeah.
But the cognitive perspective, which is really central to this article, views transfer as an active mental process that the problem solver, consciously controls. It's about how we think about and utilize our knowledge.
Okay.
And this leads to the question of what makes transfer strategic. The article references Brown's idea of knowing where, when, and how to know, and also Mayer's framework of declarative knowledge, knowing what, procedural knowledge, knowing how, and strategic knowledge.
So declarative is the facts, the info. Procedural is the steps, the skills. And strategic is knowing when it's appropriate to use those facts and skills and how to apply them effectively in different situations.
Exactly. And for our discussion today, based on Fai's article, strategic knowledge is essentially synonymous with this spontaneous transfer we've been talking about. It's the ability to not just possess the knowledge, but to recognize its relevance and apply it without needing external cues or prompts.
Now, the article also brings up this interesting distinction between online and memory-based processing when it comes to transfer.
Right.
What's the key difference there?
Yeah, this is a really important point. Online transfer typically happens when you're actively engaged in a task and getting immediate feedback.
Okay.
Think about practicing math problems in a textbook where you can check your answers right away. You're using the examples, the feedback, to guide your thinking in that immediate practice session. Memory-based processing, on the other hand, is when you have to apply that knowledge later, maybe days or weeks later, without any immediate prompts or feedback. Like facing a novel problem and needing to remember and apply the relevant procedures entirely on your own.
So online is like having training wheels on. You're getting support in the moment.
Good analogy, yeah.
Memory-based is when the training wheels are off, and you have to rely solely on what you remember. And the article suggests that educators might often assess the online transfer, like, can the student do the practice problems with support?
Right.
But then they just assume that memory-based transfer will automatically follow.
That's the crux of it. And this connects directly to the inert knowledge problem, a concept Whitehead discussed way back in 1929.
Inert knowledge.
Yeah, it's the idea that students can acquire knowledge in a classroom setting, learn it for the test, but then fail to apply it in new real-world situations where it would actually be perfectly relevant.
Wow.
The knowledge is there, it's available, but it's not active or accessible when needed. It's just inert.
That's a powerful idea. So if we only evaluate someone's ability to solve a problem with immediate guidance and feedback, we might be overestimating their capacity to actually use that knowledge independently later on.
Precisely. And this leads the article to frame strategic transfer as this crucial tool for demonstrating true problem-solving competence. It shifts our focus from just defining transfer to really considering how do we study knowledge transfer in a meaningful way.
Okay.
It's about seeing if that learned knowledge can be effectively deployed when the situation demands it, without explicit instructions or reminders.
Okay, so strategic transfer. Spontaneous, memory-driven retrieval of learned methods for new academic challenges. Now let's dig into that memory-driven aspect more. What does the article tell us about the memory foundations here?
Right, this is where the theoretical underpinnings get really significant. The article highlights the influential work of Endel Tolving.
Totally, okay.
Yeah, particularly his ideas around encoding and retrieval processes, the distinction between knowledge being available versus accessible, and the different types of long-term memory, specifically episodic and semantic memory.
Can you quickly remind us of the difference between episodic and semantic again?
Sure. Semantic memory is our general knowledge about the world, facts, concepts, vocabulary, stuff we just know. Like knowing Paris is the capital of France.
Got it.
Episodic memory, on the other hand, is our memory for specific events and personal experiences, often tied to a particular time and place, like remembering your first trip to Paris.
Okay.
Tolving emphasized that while classroom learning often focuses on building semantic memory, the facts and concepts, these two systems are deeply interconnected. He actually considered episodic memory a more specialized form of semantic. And crucially for transfer, he argued that remembering past problem-solving experiences, which is often key, likely involves accessing elements of episodic memory, recalling the specific context where you learned something and how you applied it.
So it's not just knowing the rule or the formula, that's semantic, but maybe also remembering when and how you successfully used that rule or formula in the past. That's episodic. That makes it easier to apply it again in a new situation.
Exactly. And then we have that crucial distinction between availability and accessibility.
Right, you mentioned that.
Availability just means the knowledge is stored somewhere in your long-term memory. It exists. Accessibility is whether you can actually retrieve and use that knowledge spontaneously when you need it.
Ah.
Something can be available in your memory banks, but for various reasons, you might not be able to access it at the critical moment.
That really brings us back to that initial idea of the locked vault, doesn't it?
Totally.
The information is in there, it's available, but we can't always get the key to open it. It's not accessible.
Precisely.
Yeah.
And the article points out that the way researchers design their studies, like whether they compare different groups of people between subjects or track the same people through different tasks within subjects, can significantly influence whether they're measuring availability, accessibility, or both.
So a study might show someone can recognize a concept when prompted, which shows it's available.
Mm-hmm.
But that doesn't necessarily mean they can retrieve and apply it on their own in a novel situation, which speaks to accessibility.
Exactly. Now, the article then dives into two primary lines of research, offering different perspectives on how transfer happens. One is called transfer-appropriate processing, largely associated with Bransford and his colleagues.
Okay, that's fair.
And the other is transfer-appropriate procedures, stemming from the research of Roediger and his team.
Okay, so two different lenses to view this transfer puzzle. Let's start with transfer-appropriate processing. What's the core idea behind that one?
The central idea of transfer-appropriate processing is that transfer is most likely when the way you process information during learning the encoding phase matches the way you need to process it later when you're trying to retrieve and use the retrieval phase.
Okay.
It's all about creating compatibility between what you do with the material when you learn it and what you'll need to do with it later.
So if I need to remember a piece of information by its meaning later, I should probably focus on understanding its meaning deeply when I'm learning it, rather than just, say, memorizing how it looks on the page.
That's the fundamental idea. The article traces how this model evolved, starting from earlier ideas about deep processing leading to better memory. But then Morris and colleagues argued it's not just the depth of processing, but the type of processing that's crucial for successful retrieval.
So if I need to recall a list of words based on their rhyme later on, I should probably pay attention to the rhyming sounds when I'm learning them, rather than just focusing on what the words mean.
That's a perfect illustration,
Yeah.
exactly. And this model also really emphasizes the role of elaboration during learning.
Elaboration.
Yeah, like actively explaining information in your own words, connecting it to what you already know. Stein and Bransford's research showed this significantly improves retention, but, and this is key, only if those elaborations help clarify the significance of the information you're trying to learn. Just any old connection isn't enough. Asking yourself relevant why and how questions can be a very effective way to elaborate meaningfully.
So passively reading something over and over isn't as effective as actively engaging with it, building those meaningful connections.
Precisely. The research also showed how our prior knowledge, both specific past experiences, episodic, and general knowledge, semantic, shapes how we process new information. This led to the concept of abstract frames or schemas.
Schemas,
Yeah.
right? Those mental organizers, they help us fit new information into our existing understanding.
Exactly. Morris and Bransford's work on inferential reasoning showed that when we actively integrate new info into our existing schemas, it strengthens our ability to draw conclusions and make inferences later.
Right.
And there was a series of studies with fifth-grade students that really brought this to life. They found that more successful learners naturally used more effective elaboration strategies, making richer, more precise connections.
Interesting.
But importantly, they also found that these elaboration skills could be taught. Less successful learners could improve their performance significantly with the right training.
That's really encouraging, that these effective learning strategies aren't necessarily fixed but can be developed.
Absolutely.
And the article mentioned different qualities of elaboration, like distinctiveness, complexity, precision, and how they affect memory.
Yes, Stein and his colleagues found that elaborations making the information more distinct from other info, more complex by linking it to related concepts, and more precise by clarifying key details all contributed to better retention. It wasn't just making any connection, but making good, specific connections.
Now, the article also discussed a shift within this transfer-appropriate processing framework towards focusing more on the accessibility of prior knowledge. What was that about?
Yes, this was work by Perfetto and colleagues. They made this really interesting observation. Even when people had been exposed to information that could help them solve a later problem, they often didn't spontaneously use that information unless they were explicitly told about the connection.
Huh. So just having the knowledge wasn't enough.
Exactly. It really underscores that simply having knowledge stored, availability, doesn't guarantee you'll be able to retrieve and apply it when needed, accessibility.
That's such a critical distinction. You can have the right answer somewhere in your brain, but if you don't recognize it's relevant or know how to pull it out in the current situation, it's not much use.
Totally. Think of knowing a specific function in a software program. You might know it exists, but unless you realize now is the time to use it and remember how, that knowledge isn't helping.
Yeah, exactly.
Their work also looked at generation effects, the idea that actively generating an answer yourself boosts memory. But again, they found that even when people actively elaborated during learning, it didn't automatically lead to spontaneous retrieval later. Elaboration helped, but it wasn't a magic bullet for access.
Okay. And then there was that study by Adams and colleagues on problem-solving tasks.
Right. That study indicated that processing information with a problem-solving focus during learning only really facilitated spontaneous access later if the content and the types of thinking involved were similar in both phases, learning and problem-solving.
So that really reinforces the core idea of transfer-appropriate processing.
Yeah,
The match matters.
precisely. And this whole line of research ultimately contributed to the development of anchored instruction, an approach Bransford strongly advocated for.
Anchored instruction.
Yeah, this involves creating engaging, often video-based problem-solving scenarios where learning is deeply embedded in a meaningful context. The aim is to tackle that inner knowledge problem head-on
How so?
by allowing learners to engage in extended exploration and see how experts actually use knowledge as a practical tool in situations that feel more real.
So instead of just learning abstract principles in isolation, you're learning them within the context of a realistic problem you're trying to solve.
Exactly. It's about making the learning experience more relevant, showing learners why this information matters and how it can be applied practically, making those connections clearer from the start.
Okay, that gives us a solid grasp of the transfer-appropriate processing perspective. Now let's shift to that second key research area. Transfer-appropriate procedures from Roediger and his colleagues. What's their main angle?
Right. So while transfer-appropriate processing primarily looks at encoding what happens during learning, transfer-appropriate procedures places more emphasis on retrieval, how we access and utilize our memories later.
Okay, focus on retrieval.
Yeah. This perspective emerged alongside big developments in memory research, moving away from just identifying distinct memory systems towards understanding knowledge representation and the relationships between different ways we assess memory.
So instead of asking, is this semantic or episodic memory,
hmm
they're more interested in, like, how are we trying to retrieve this info and how does that influence what we can access?
Exactly. Hintzman's schema abstraction model is relevant here. It proposes, interestingly, that we might have a single memory system storing records of individual experiences' episodic traces.
Zinkel system. Okay.
And abstract knowledge, or schemas, aren't stored directly, but are constructed on the fly at retrieval by generalizing across similar past experiences.
That's a fascinating idea. So when I face a new problem, my brain isn't pulling up a pre-made solution file, but it's accessing memories of similar past situations and kind of creating a generalized strategy based on those.
That's the core concept. This model helps explain both online transfer during practice and later memory-based transfer. It really puts importance on the decision-making processes happening at retrieval.
And the article connects this idea constructing schemas at retrieval to academic problem solving, where students need to remember and adapt previous lessons for new problems.
Precisely. It highlights that this process is easier when the procedures and strategies learned are well defined. This leads us to Roediger's transfer-appropriate procedures model. He argues against separate memory systems and instead emphasizes the functional differences we see between various ways of measuring memory recall, recognition, implicit tests.
Okay.
His argument is that the way we probe memory dictates what kind of information we can access and how we can use it.
So a multiple choice test recognition might tap into memory differently than an essay question recall.
Exactly. He and Schachter also drew that crucial distinction between explicit and implicit measures of memory. Explicit tests are where we consciously try to remember, like a standard exam.
Hmm.
Implicit tests, however, assess the influence of past experiences on current performance without conscious awareness of that influence. And a task requiring strategic transfer spontaneously using prior knowledge could be seen as a form of implicit memory test.
Ah, okay. So implicit memory tests are really getting at that automatic spontaneous access we talked about right at the start.
Exactly, and Roediger argues that research on implicit memory, precisely because it inherently looks at how past training affects new situations, has the potential to revitalize the study of transfer of training, which he felt hadn't gotten enough attention.
Interesting. It sounds like these two perspectives, processing and procedures, while having different focuses, actually kind of complement each other, right?
Yeah.
They give a more complete picture.
Absolutely. And the article proposes a training for transfer paradigm as a way to integrate both approaches, moving towards a more comprehensive model of academic problem-solving competence.
Okay, what does that paradigm look like?
Typically, it involves a training phase where new info or procedures are learned, then a memory test to check initial learning, and then a transfer task to see if that learning can be applied in a new context.
Right.
This lets researchers study both encoding, processing, and retrieval procedures while trying to control for other factors that can muddy the waters when studying transfer.
So you're not just looking at if transfer occurs, but trying to understand the mechanisms why it happens sometimes and not others.
Precisely. This approach allows for systematic changes to the learning and testing conditions to figure out what really promotes or hinders transfer. The article also briefly touches on motivation here.
Motivation's role.
Yeah, suggesting motivation isn't just a general trait, but can be specific to the demands of remembering and problem solving in a particular situation.
So my motivation to remember something for a high-stakes exam might be different from recalling a fact in casual chat, and that could impact my access.
Exactly. The article mentions Jacoby and Kelly's work viewing motivation through an episodic memory lens, proposing memory isn't just a passive store of the past, but an active tool we use now to guide behavior. They suggest memory can motivate us in several ways in cognitive tasks.
Okay.
Ultimately, successful academic problem solving hinges on remembering relevant prior problems, how they were understood, and the strategies used. Competency really comes with practice at both encoding effectively and retrieving flexibly.
Okay, so it comes back to practice, but strategic practice, focused on both learning and later application. Now, the article also addresses that common question. Why don't we see more transfer between different subjects or domains? It feels limited sometimes.
Yes, a very pertinent question. From the information processing perspective, the article argues we wouldn't necessarily expect widespread transfer between very different domains unless the learner has a history of processing information in ways relevant to both.
Oh.
Both the transfer-appropriate processing and procedures models suggest that a lack of similarity in how info is encoded and how it needs to be used would limit transfer. Makes sense, right?
Yeah, it does. So if I only learned a math concept within algebra problems,
Yeah.
I might not automatically see how it applies to a physics problem unless I've had specific experience bridging those areas.
Exactly. The article also notes that domains themselves can be defined differently by formal subjects, math, history, by problem types within a subject, by discipline boundaries, or even by the fundamental cognitive processes or procedures involved. And it points out these different definitions aren't necessarily contradictory, just different focuses within the learning experience.
And the article concludes by emphasizing what? What's the final word on studying this?
It urges a sharper, more theoretically driven focus. Rather than just compiling studies showing some influence of prior knowledge, we need a more rigorous approach. And crucially, it cautions against searching for a single high road or a magic bullet for transfer.
Right. No one-size-fits-all solution.
Precisely. It's complex. Understanding it requires a nuanced view considering how we learn, how we remember, and the specific demands of the problem context.
Okay, so let's try to crystallize the key takeaways for our listener. What are the most important things to remember from this deep dive?
Well, I think the core ideas are, first, strategic transfer, that spontaneous access and use of learned knowledge is absolutely vital for effective problem solving. It's not just nice to have, it's crucial.
Right.
Second, it really depends significantly on how you initially learn and encode information and how you later try to retrieve it. That match matters.
Right.
Third, things like focused practice, getting relevant feedback, and developing a deep understanding of the underlying structure, not just surface features, all play a big role in enhancing transfer.
Okay.
And maybe most importantly, actively engaging with your own learning process. Consciously thinking about how you're taking info in and how you might need to use it later can really transform prior knowledge from something inert into a readily available, powerful tool.
That's a really insightful summary. It makes it so clear that learning isn't passive absorption, it's active preparation for future use.
Exactly.
So here's a final thought for you, our listener, to consider. In your own areas of interest in learning, how can you intentionally refine your learning methods to make sure that the knowledge you gain becomes truly accessible and transferable when you need it most?
Think about specific situations where you found yourself struggling, to access knowledge you knew you had. How might these ideas in coding specificity, transfer for appropriate processing, even just availability versus accessibility, shed light on that experience? It's really about taking the reins, isn't it? Making sure that Mental Vault is always open when you need it.